Hello everybody, it is Jordan Yates, and today I'm here at TDK-Lambda Americas in Plano, Texas with Bossy, one of their field applications engineers. Bossy, say hello to everybody.
Hey, hello everyone.
So today we're going to be going over their low audible noise QM/MU product series. Now this addresses the importance of noise reduction in sensitive areas, is that correct?
That is correct, especially in hospitals
Yes.
and medical facilities.
Absolutely, and that's exactly what I want to talk about today. In medical applications, clinics, and hospitals, excessive noise can be a stressor for both patients and the medical staff, potentially impeding both recovery and concentration. And this just isn't something that TDK was okay with, so they came up with a solution for it. Now, can you explain to us how medical facilities can ensure their vital equipment meets stringent noise reduction standards without compromising power or performance?
Sure, should do it. So in medical equipments, most of the medical equipments need a power supply, an AC/DC power supply. In AC/DC power supplies, there is a fan which is used to cool the semiconductors which are used in there and other components. So the fan makes a lot of noise, and there are a lot of people who really want to just get away with the noise. So TDK came up with a quiet module, as we call it. The fan runs much cooler because the efficiency of the product is pretty high. And we also have a new product line called the MU4 series, in which we have a smart fan control. So what the smart fan control does is it monitors the different spots in the power supply. And only when the temperature inside the device gets hot, that's only when you need the fan to run at high speed. And it will run at high speed when the devices run hot, but most of the time it is not required to run at full speed.
It sounds like a very intelligent device. Now, I don't know if you guys guessed it, but what is going on behind us is everything we're talking about. We got the product here and a bit of a demo. So do you want to walk us through everything we're looking at?
Yes.
So Bossy, now we have the demo in front of us. Can you walk us through which part of this is the actual product and then how it works for the low audible noise?
Sure, Jordan. This is one of our power supplies. This is what we call the MU series power supplies. And the MU series power supplies has got, this particular one has got multiple outputs. It's got a 48 volts output, 24 volts output, 12 volts, and 5 volts output. And right now, this power supply is feeding into different multiple loads, just similar to what you would see in a hospital with multiple equipments being run from the same power supply. And this is running at light loads at this time, and then you can see that this fan is running almost, I cannot even hear that fan running at this time.
So this is on right now?
This fan is on. This is powering this power supply.
Okay, so let's give them a listen. Like obviously guys, we're talking into the mic so you can hear us, but let me put this mic right next to the fan. Really not much change. Okay, so as you can tell, that is incredibly quiet. So back to the rest of it. What else is going on?
When the unit is providing higher outputs, like for example 600 watts output, there are some losses happening in the power supply that will raise the temperature inside this box. So when the temperature goes, or the load goes up to 80%, that's when, and the losses go up, the fan will detect that the temperature rise in different elements of the power supply, and it will turn on or ask the microcontroller will ask the power supply to run at faster speed. And you probably can hear it as it's heating up. As the elements in this heat up, the fan slowly starts to ramp up in speed.
Okay, so it's pretty neat how it's responsive to the power needs and the heat, and it's very intuitive, it sounds like. It's not just a steady one power, one noise. It fluctuates a little bit.
Right. So the microcontroller detects what is the situation of this power supply. If it is not running at full load, then there is no reason for the fan to run at high speed. Because in hospitals, most of the time, all the equipments are not run at the same time, but we have to design it for the maximum power in the system. So when it is running in the normal, it is usually running at less than 50% of the load, and there is no reason to run the fan that fast, because the product components inside are not getting that hot.
Yeah, that makes a lot of sense. It's really cool that you guys came up with a solution for this problem that does affect so many people. Is there a way that if somebody wants to learn more about this, they can reach out to you? What would be the next steps if this is something that's interesting to them?
So they can contact our help desk, a help desk line we have at TDK Help Desk, and you can contact them, and then somebody will be able to answer some of the questions, or it will come directly to us. We have 2 or 3 FA field applications engineers in US, and one of us will get back to you and then address your concerns.
Sounds great. Well, guys, I'll put all the info in the description below if you want to reach out and learn more about this. So thanks so much for watching, and we'll see you next time.
Thank you.